This is a high-level view of the semiconductor manufacturing process. This manufacturing process has simplified 15 steps. That's the basic flow of the materials. This includes extracting raw materials such as sand, which leads to ingot formation. You create a wafer from it and polish it. Other processes, doping, photolithography, etching, ion implantation, deposition, annealing, and chemical mechanical polishing, follow this. After this, you do packaging, testing, and check the quality. It is then ready for distribution and integration for the end product. Here, we show a macro view of the semiconductor manufacturing. The sand turns to ingots, which are then sliced into wafers and processed to produce a completed die from the finished wafer. It goes through a process with all kinds of gases and other chemical and photochemical processes. These are the drawings of the ingots. The process involves melting polycrystalline material, and crystal growth is initiated after the seed contacts the melt. After the necking process, the crystal is pulled and cooled down. Look at this layout picture, where many layers and steps are used to put a transistor into silicon. It's like stencils and paint with multiple layers. Analog teams better know about this. They are like the artists using stencils and spray cans while we spray different kinds of gases and things under heated conditions across a stencil to get the various layers. These planar field-like transistors are simple. An EUV extreme ultraviolet is one of the steps in the lithography process for the stenciling of the chips. The extreme ultraviolet EUV lithography employs light with a wavelength of 13.5 nanometers. Generating this type of light is exceptionally challenging. The process involves pulverizing a small tin ball with powerful lasers, causing it to explode into a plasma hotter than the sun's surface. This plasma emits EUV light at the precise wavelength needed. The set of ultra-flat mirrors, the flattest ever created by humans, collect and reflect this light onto a silicon wafer. It is like one of these really interesting, intricate machines. So, there's actually a drop that comes down and gets hit with a laser. It emits the right wavelength of light, and you can then pattern these fine geometries there. There's a big breakthrough.